I'll give you $1 for it.
Okay, so today, you note-taking fools, we're going to be talking about linear functions. Now, you already know about linear functions. You know a lot about them. So let's talk about what you know. What do you know about linear functions?
It's a line.
It makes a line, right? What else do you know?
None of the x's are the same.
No x's the same. How do we know that?
Because it's a line.
What if it's like this?
That is a line that the x's are the same on and is not a function. That's a vertical line, right? So how do we know that no x's are the same on a linear function? Hey, because it's a function. If it's a function, none of the x's can be the same, right? So that's how we know that there's no x's the same, is because it is a function. Okay, how do you tell by looking at, and I'm going to zoom in real close so that y'all can't see. Hang on just a second. How can you tell that it's a function based, a linear function based on the equation? Hold your horses.
If the x's aren't the same.
Okay. Try it again. I give you these equations right here. And I say, okay, which ones are linear and which ones are not? How do you tell?
Next.
You have that piece of paper there in front of you that I told you you needed to have? You need to be taking some notes, right? Number 1 through 8.
What do you want us to do?
Are you laughing at me, Bill? It's that. I want you to write down 1 through 8 on that piece of paper. I'm fixing to tell you what I want you to do. You got 1 through 8 written down yet? Y'all some slow people. I don't care. I ain't picky. I'm not going to look at your paper, so I don't care. It doesn't matter to me. You do it however it floats your boat. Will you grab my cup, my red? Will you grab my red cup off my desk and get me some too, please? Okay, for each one of these, I want you to decide if you think it is or is not a linear function. So you're either saying yes, it is a linear function, or no, it is not a linear function. So yes, it is. No, it's not for each one. And we're just going to do this real fast, and then we're going to see what y'all think. Is it linear or is it not? Do y'all just want something besides the popcorn? I smell peas. Does anybody else smell peas? Peas. Like green peas, English peas? Peas? Just me? Okay. You got all your 8 answers? Everybody got all 8 answers? wonder if I could. Thank you so much. Y'all are literally about to drive me crazy today. I don't know what. Okay, number one, what do y'all think? Yes or no?
No, yes.
You think that one is?
Yes.
Number one?
Yes.
What about number two? What do you think about that one?
No.
How about number three?
No.
Yes, it is.
Yes. I said
No.
yes.
Yes, it is.
How many yes? How many no? Oh, we're split. Okay. Number four.
Yes.
No.
Yes. I said yes.
Who said yes? Who said no? Number five.
Yes.
Yes.
No.
Number six.
Six?
No.
No. No.
Y'all are very adamant that one's no. Why are y'all so adamant that one's no?
It looks like a
It feels like a no.
Kaden, I thought it was.
Feels like a no. How about seven?
It feels like a yes.
No.
Yes.
No.
Yes.
How many yeses on seven?
No.
Don't change your mind just because they say, because, I mean, you're relatively smart, so. Okay. What about no's? Who said no's? Okay. Number eight.
Yes.
No.
Yes.
No.
No.
No. I said no.
You already raised the answers?
They're all yes.
Everything in column one is linear.
Oh my God.
Everything in column two is non-linear.
Hey, that's too crazy.
What?
You're annoying.
Did you get that right?
I got,
He said yes and no for both colors.
I got like 2 wrong.
I got them all wrong.
Did anybody get all 8 correct? You did? Theo's lying. You might get 6 correct. 5. You may get 5 correct. See, look at y'all.
I got 6 correct.
Okay. Now, let's talk about it, okay? Y'all listening? This one, let's talk about why these are linear and why these are not linear. So, for an equation to be a linear equation, your variables can only be x and y. Okay? You can't have anything other wild variable. That right there is exactly what I'm talking about. That has been going on all day long. I had one kid in my engineering class pick up another kid and swing him around. He was in a chair. It gets worse. It's been all day long like that. So just keep your hands to yourself. Okay? Y'all ready? Okay. Only X and Y, nothing else. Just X and Y. Right? Your X and Y can be added or subtracted to each other, but no other operation. You can't multiply X times Y. Now you can multiply things times X and times Y, but not X times Y. Y'all understand the difference between that? So like we can multiply 4 times X and 5 times Y, but we can't multiply X times Y. Y'all see? That's why number 7 was a no. You can have fractions in your problem. You can have fractions. And I want to point out that this 1/2 x could have been written as x over 2 because 1x divided by 2 is the same as 1/2 times x, right? Those could have been written like this. You can have fractions in your problem, but you can't have a variable in the denominator of a fraction. So this x can't be down here. You'll see that. This, totally okay. This, no bueno. Alright? You can't have any operation that's different, that's beyond multiply, divide. Right? So you can add, subtract, multiply, divide. If you've got a square root, or a square, or a cube, or anything else, a cube root, can't have that. It's non-linear. It becomes something else. It actually becomes this one becomes exponential. This one becomes a root function. We'll talk about those more later. But do you see now how you tell, is it linear or not? All right, fix and quiz you again. Let's see if you get this one right. My eyes are really bad today.
Did you say not right there? Not like that. But like this is we got like oh me.
Okay, you ready? I'm going to give you why is this not bending? Okay, let's try the first 5 together. Okay? 16.
Yes.
Yes, 16 is linear. 17.
No.
Why not?
Because it's a square.
Because it's a square. 18.
No. Well,
I don't know.
Yes. It's multiplying.
As a square root.
Okay.
18.
Wait.
18's
Oh,
okay.
I was looking at 22 my fault.
Hey man, what you talking about, bro?
And he says, I was looking at 22.
Yeah. Clearly not. I'm on
Were you going down?
Yeah, I was
Okay. So this, in this case, this is not h times x. That's not what that says. That doesn't say h times x. That says the function of x. We're just using h as function, right? So this is actually y equals 6. Now y equals 6 would be a horizontal line, because no matter what x is, well, no matter what x is, y is 6. X is 0, y is 6. X is 10, y is 6. X is negative 10, y is 6. And that creates this horizontal line. A horizontal line. Okay? Is a horizontal line a function? Yes. This one's a yes. Oh, don't let me forget to erase that. Okay, what about this one? Yes or no?
No.
Why not?
Square root. I mean.
The squared, right? That power of 2. Okay, what about this one?
No.
Why not?
The variables on the denominator.
Variables with a denominator. What about this one?
No.
Square root. No square root. What about this one?
No.
What about this one?
No.
What about this one?
No.
Well, y'all violent sounding. Who thinks this is a yes?
That's true.
Who thinks this is a no? Chat said yes. I wouldn't go with chat.
I told you it was no, right?
It is yes. It is yes. Now, let's talk about why this is okay. What about this did we think maybe was an issue? Okay, remember you can have fractions. Your variable just can't be in the denominator. But you can have fractions, okay? You just can't put the variable in the denominator. Alright, so that is some basic bottom of the line, making sure we understand what it looks like. Now let's talk for just a minute about standard form. Do y'all remember standard form of a linear equation? Anybody remember that? Whoever watches this video later is going to be like, what is up with Miss Martin? Okay. Standard form of a linear equation looks like this.
You can't see it.
It's supposed to be a surprise. Hang on. Ready? Ready? It's like magic, y'all. Like it wasn't there and then it was. It just appeared on the paper. Y'all know Luke Pierce?
No.
So when I had Luke in Algebra 1, he started calling this Ax by C. Ax by C. That's what he would call it. And that has stuck with me all this time. So now in my head, I call this Ax by C. Even though what this is actually called, that's broke my brain, is standard form of a linear equation. Okay, so that's standard form. Now, you guys know another form of linear equation. As a matter of fact, normally when I say the word linear, somebody shouts it out. Y'all know what I'm talking about? Every dang time. All I gotta do is write y equals and somebody's gonna yell it, right? What's this one called? Does anybody remember? Slope, intercept, form. And then there's a third option for the way to write a line. Does anybody know what our third option is? That doesn't even make sense. Like, literally, was it even possibly what we were talking about?
One.
No, I do not remember this at all.
You don't remember this one?
Not at all.
This.
Point, slope, form. That one's called point, slope, form. Now, we're going to come back to point, slope, form and slope, intercept, form and spend a lot of time with both of them. But for right now, in this moment, we're going to talk about standard form. Now, standard form, A is a number, B is a number, and C is a number, right? But what if the number is 1? Like, what if A was a 1? What would that look like?
What did you say?
Yeah, so it'd be like just X, right? So it'd be like 1X, well, we would just write an X, right? Or if it was 1Y, we would just write a Y. So if you see just a Y, like if you have like 2X plus Y equals C, what is your value for B in that case?
1.
It's 1, right? What if your B was a 0?
Just 2 X's.
B what?
So if your B was a 0, and that was 0Y, but what is 0 times any number in the world? It's 0. So you're going to have 2x equals C. Technically not a function, by the way.
Oh. I heard you.
Okay, y'all with me so far? Okay, now, when we're writing in standard form, you want your A, B, and C to be integers, right? Your A, B, and C, you want it to be integers. So that's going to make a difference when we do problems like what we're about to do in just a minute. I swear, my eyes are so bad today. But I do have a headache, and I think that's probably why. Okay, here's a linear equation. We know it's linear, right? It's a nice, pretty linear equation. And we want to put it in standard form. We have two options here. Number one, what is something we're going to have to deal with? That fraction. In standard form, your A, your B, and your C cannot be fractions in standard form. They have to be whole numbers, right? Integers. Positive, negative, integers. Okay? But the other thing we got to deal with is it's not in the right order. So there's two things we have to do. We have to get rid of the fractions and we got to put it in the right order. And it doesn't matter which one we do first. Doesn't make any difference. You're still going to wind up with the same answer. Now, does anybody have any ideas on how we can get rid of that fraction without changing everything?
30. Make it a decimal.
Can't make it a decimal. It's got to be an integer.
Times 10.
I don't know if y'all heard Diego at the very beginning before anybody started saying anything, but at the very, very beginning, I want to give him credit for this. He said, multiply by 10. And that is accurate. We're going to multiply everything by 10. Okay? Now, there are some... Well, I'm going to check this out before I tell you that for sure. If we multiply this by 10, what happens to this 10 and this 10?
They multiply and cancel them.
And that leaves us with negative 3x, right?
Yes.
And then we got that equal sign still. But then we still got to multiply this by 10. What's that going to be?
8.
And then if we multiply this by... Okay. Now we still don't have it all in the right order, right? So what are we going to do next?
Move the 50 from to the left.
We got to move that 150? No.
Now move to 80.
Move the 80. We got to move that 80. How are we going to move that 80?
Subtract it.
Subtract 80. Subtract 80, right? So that gives us negative 3x minus 80y equals negative 150. Now, there is this like, I don't know the word I'm looking for because my brain can't process stuff. There are some who say that your leading coefficient, which is whatever is in front of your x, has to be a positive. And then sometimes you'll see that it's a negative. Okay? If we wanted to make it a positive, if we wanted to make negative 3 a positive, how could we do that? What could we do to make that negative 3 a positive 3? Multiply it by a negative. By any negative?
1.
I mean, technically we could multiply it by any negative. It was not going to change it. 1. Multiply it by 1, that's not going to change it, right? So we multiply everything here by negative 1, that changes nothing except all the signs. So this is going to become positive 3x, positive 80y, and positive 150. Now, like I said, sometimes you're going to see this with a negative, and you're going to be like, Ms. Martin, you said that couldn't be a negative. It's not supposed to be. People still use it. People still write with it and do it, but technically, in correct format, you're not supposed to have a negative for your A. Okay? Okay, y'all good so far? That's not that hard, is it? That ain't bad at all. All right, how much time do we have?
30 minutes.
Do we really have 30 minutes?
Absolutely not.
14? Okay, perfect. All right, let me make sure I've got what we're looking for so far.
That's right there.
Okay, do you remember x-intercepts and y-intercepts? Do y'all remember those? So if you have a graph of anything in the world, and you're talking about its x-intercept, yes sir, that means where the graph crosses the x-axis, right? If you're on the x-axis, remember the x-axis is the one that spreads out, right? Like an x does. It spreads way out. If you're on the x-axis, this guy right here, what is the one thing you know is true no matter where you are on that axis? What has to be true? Anybody know? I know you are sitting there thinking this is a trick question, but it's not. It's just a thinking question. If you're anywhere here on this axis, anywhere at all,
It's going to be 0.
what's going to be 0?
The x will be 0.
Is the x 0?
No, I mean the y Why is
The y is 0. If you're on this axis right here, just like Mark and Daniela said, y is 0, right? Because you're not going up or down if you're on that axis. You're not going up, you're not going down. You're not going up, you're not going down. You're on the axis. So if I have an equation and I want to find the x-intercept, I just need to make y 0. And that will tell me what x is when y is 0. So if I have an equation like, it should not be this hard for me to just make up an equation. Okay, so we have an equation like this. And I want to find the x-intercept. The x-intercept is whatever x is when y equals 0. So for where y is right there, guess what I'm putting right there? I'm putting 0. And then I'm just going to solve for x and discover what is x when y is 0. So what do you have when you do 3 times 0? So we've got 2x minus 0 plus 8. What do we write down? Plus 8. Okay. Now what? I heard somebody say it. Subtract the 8. Then? So what is x?
4?
Almost.
-4.
Yep. So this is a point. This is the point 0, -4. I said that backwards. This is the point -4, 0. Because y was 0, x is -4. Now, the exact same thing exists with your y-axis. On your y-axis, what is the one thing we know is true all the way up and down through there? X is 0. X is 0 everywhere on that axis. So if I want to find the y-intercept, I'm going to stick 0 in for x. Because I want to find the value of y when x is 0. What is y in this equation when x is 0? So if I look at this equation right here and I say, oh, I'm going to put 0 in for x, this is what I got, right? And so what is 2 times 0? 0. And then 0 minus stuff is just whatever that stuff is, right? So we got this. Then what? Subtract 8. Somebody keeps saying that very quietly. I can just faintly hear it, almost to the point that I think I'm dreaming that they said it. Okay, so what do we do next? Now, what is that going to be? Fraction or decimal, according to how you look at it, right? What's a negative divided by a negative? It is going to be a positive. Now, how many times is 3 going to 8?
2 times.
2 times with how many left over? 2. So it's 2 2/3 or 2.6 repeating what it is. Now, this is a point. Our point is x is 0. Y is, I'm writing this in the wrong spot. X is 0. Y is, this is why I cannot use mechanical pencils, y'all. I broke this lead like 3 times. 2 2/3. Yes, Lois. Yes. You can't see that right there?
Oh.
Okay. So, when x is 0, we're not going left or right. Y is 2 2/3. I'm estimating here. Okay. Over here, when x is -4, 1, 2, 3, 4, y is 0. That's that one. And that, where I totally and completely miss my points, is our beautiful line. Okay? It's harder to do this than what you would think. I'm just saying. Okay. Does that make sense? Do y'all remember those? Alright, let's do a few. Let me give you a couple to do. Let's start. I want you to try to put these 4 in standard form. Let's try that first. Put those 4 in standard form. Y'all can talk, it's okay. Anybody want to come up and do one? Nobody? Those of you who use mechanical pencils as your everyday writing utensil, how do you not break the lead? Yes, I just don't know how to do that. Okay, you ready to work a few? Anybody want to? Does anybody want to volunteer? We're getting no volunteers here.
If this is right, I'll do
If the first one's right, you'll do the second one. Is that what you're saying?
it. Is that right?
Like I can see that from this far away. No, don't volunteer for that one. Okay, so first thing we need to do. Remember, it needs to look like this. That's our goal. What is wrong with this that doesn't make it look like that?
The Y.
We got a Y here,
I mean the X.
but the X is over here. That's really the issue, isn't it? We need to move this X the other side. So how do we do that? Since it's subtracted, it's a negative, right? It's subtracted. If we add it over here, that's going to get us 4x plus y. Now, technically, we could write y plus 4x, but we don't need y plus 4x. We need the x to be first. And then what's on the other side? Negative 7. And we're done with that one. That's it.
Okay, so I can volunteer. I can volunteer for it.
Do you want to volunteer for one?
For the next one?
How about
Okay, I got it.
Number 7?
how about that one?
Let me show you mine real quick. Then you can let me know if I should volunteer or not.
Yes, but don't hate me.
But don't what?
Continue. Go ahead and do it. Hang on. All right, hang on a second. Let me fix it. Okay. Is it up there? Okay. Alex.
Oh, I'm okay.
Okay. Can you tell him?
You have to multiply by negative.
Yes. Hey, Alex.
Ma'am.
Are you paying attention?
Yes.
Okay. So I told you to go ahead and volunteer, and I told you not to hate me because you do have a little bit of me. But what you did is not inaccurate except for one thing. There is an error there. Y'all see the error? I think you may have wrote this error when you wrote it on the board.
Yep.
Yeah. This Y,
It's added, yeah.
it's a positive, and I think you did it on your paper. Yeah. Now, this is okay, except we really want this X to be what kind? A positive. So how do we make it that way? Multiply everything by -1, right? So what does that do to everything?
Added. I mean,
Yeah, changes the sign.
Changes the signs on everything. That's all it does. Multiplying by a negative just changes the signs on everything. Hey, we're going to do some of these tomorrow for practice, okay? It'll be a work day. Plan to work.
bro. You don't want to call it?
Yeah, I don't eat carbs.
You can have a negative Y or negative.
Yeah, negative Y? Totally okay. Negative X? Bad. Does it really matter? It's just to make everybody be right the same way. Yeah. It's kind of like, you know, when you're a little kid and they teach you how to write specific numbers, they show everybody the exact same way to write them. Everybody does it the same way. I thought you were making that neat. Adios. Thanks for the offer of the popcorn. Bye. I didn't have popcorn.